extraordinary claims require strong evidence to support them. For example, when research is currently being conducted to find life on Mars, the Perseverance rover is carrying out various experiments. This vehicle moves around and collects samples. It is currently heading toward a river delta. It can drill and conduct studies such as chemistry and spectroscopy. However, every scientist I have spoken to on this project has stated that even if we find traces of complex organic compounds, which we can detect with these instruments, the only reliable way forward is to bring these samples back and examine them in our large laboratories on Earth. Moreover, it may take 20 years for such findings to be accepted, because on Earth there are structures called stromatolites, which are considered traces of the oldest living organisms on our planet. For example, they were found on the coasts of Western Australia and date back 3.5 to 3.8 billion years. Even though we have had these structures for 20 years or more, they are still the subject of debate. People still argue about whether they are signs of life. So if you have limited evidence from a very ancient period, as in this example, or if you are dealing with evidence coming from a different planet like Mars, it shows how much effort you have to put in. You have to work very hard to prove that you are not mistaken. And this brings us back to Feynman's philosophy of satisfactory ignorance. A significant part of science, in my field known as particle physics, is about errors. It is about measuring errors, identifying the errors in your observations. What are the possible sources of error? Think of it this way. If you flip a coin 10 times, it could come up heads every time. That does not mean the coin is weighted. There is a probability for that. That is why you need to understand probabilities and similar concepts. In other words, when searching for life in space, it is important to remember that proving the existence of life on Earth requires going back 3.5 billion years, because that is extremely difficult. So unless there is definitive evidence that a UFO has landed somewhere, perhaps we might receive a signal. We are searching for that. I strongly support SETI. I think that going and listening is a truly valuable scientific endeavor. So the first thing you should do is look for signs of civilizations out there. And we are doing that. But so far, we have not found anything. We have detected a few small signals, but they were not repeating signals. Then we tried to search again, and like the famous wow signal, they disappeared, right? So that is exactly the situation. I sometimes use an analogy. Imagine we are all boarding an airplane. But think about getting on a plane that has not been tested many times before. Smiles, right? Or imagine someone says, "The wings should look like this. Let's attach them. It'll be fine." Picture what that situation would be like. This is an example of how careful we must be in engineering. When building a bridge, you do not say, "No problem." Like the Golden Gate Bridge, you do not say, "Let's just put in a few bolts, it'll be fine." It has been thoroughly tested. In fact, the same applies to knowledge. Knowledge is only reliable when it has been tested. Just as a bridge cannot be a reliable structure unless it is tested. Therefore, I do not encourage people to make assumptions based on a blurry photograph taken with a 1990s era phone. I mean, say, think about it. The analogy is that this is an airplane and now let us go on and imagine that this has been subjected to a similar process of scrutiny. I have a question that I personally consider important. Does life exist beyond Earth? Most people would probably answer, it must, because the universe is so large, so old, and there are so many stars. However, it may be possible to find the answer to this within the next few years, say within 10 years, because we have space missions. We have a mission called Mars Sample Return, which plans to bring samples back to Earth and examine them to see whether there are signs of life. There are also 2 missions to Jupiter's moon Europa. One is on its way, and the other is about to be launched. These projects aim to determine whether it is a habitable environment. Ultimately, I think this question, whether we are alone in the universe, is a very big one. We certainly cannot say, yes, we are alone, but it may be possible to say, no, there is life. It is possible that we may find evidence of life beyond Earth within the next 10 years. If we find life in different places in the solar system, it will most likely be microbial. We are fairly confident about that. When I think about galaxies, I raise this question on the program because it really is an important issue. How many civilizations are there in a typical galaxy? We do not know the answer for sure, but we can make some estimates. And that is why I presented my own estimate on the program and explained why I thought that way. Ultimately, I arrived at the idea that there may be only a very small number of intelligent civilizations in a galaxy. What do you think that number is? On average, how many civilizations might there be? He said, on average, none. That did not surprise me very much. And this is part of the program. So I ask, what do we know? What kind of evidence do we have? How can we make estimates on these matters? Yes, we have solid evidence that life existed on Earth about 3.8 billion years ago. This is interesting because it is very close to the formation of Earth. When Earth formed 4.5 billion years ago, it cooled down and oceans formed on the surface. Shortly thereafter, we have evidence indicating the presence of life. So this is the nature of the observations we have. It makes one think about what the origin of life might be like when the right geological conditions exist. It shows a transition from geochemistry to biochemistry. In any case, we are talking about a geologically active and biologically active world. So under the right geological conditions, based on the evidence from Earth, the origin of life does not seem impossible. Perhaps we are very lucky on this planet. But under the right geological conditions, when we ask about life beyond Earth in the solar system, the strategy can be said to be going to places where there is liquid water, where there is geological activity, and where the right chemistry is thought to exist. In the past, we talked about Mars or perhaps Jupiter's moon Europa. Now we also talk about Saturn's moon Enceladus or other moons of Jupiter and Saturn. So our strategy is to go to places that are considered suitable in terms of geology and chemistry, and to study those regions. Ultimately, that is all we can do. Therefore, if we discover some form of life on these moons or in the depths of Mars, I would not be very surprised. However, if we find complex life forms, I would be truly surprised. Because the evidence for multicellular life on Earth only goes back to about 1 billion years ago. Or perhaps 600–700 million years. The evidence from Earth shows that life remained in simple forms for about 3 billion years. That is why many biologists say that microbes may be common throughout the solar system. But finding complex life would be extremely interesting. As I mentioned before, this is one of the questions I am genuinely curious about, and I think we may be very close to finding the answer. If there are no answers at all, we will never be able to answer this question, because we can never say anything with certainty, and let me explain why. In fact, we were making some measurements. The first question was to find out how many other planets there are. 20 years ago, we knew nothing about planets outside our solar system. Now we know that almost every star we see has a planetary system around it, at least one planet. Based on data obtained from the Kepler Space Telescope, we estimate that there may be as many as 20 billion Earth-like planets in the Milky Way galaxy. We have currently discovered about 1,700 planets and confirmed their existence. So wherever we look, it seems that every star we see probably has a planetary system. So there are many planets. Do they have life on them? How can we know this? We can now look at light with our telescopes. Imagine a star and picture a planet passing in front of that star. Some of the light from the star passes through the planet's atmosphere and reaches our telescopes. This allows us to perform chemical analyses. We examine the planet's atmosphere. In this way, we hope to find signs of life in the atmosphere. An example for Earth could be oxygen. Most of the oxygen on Earth is produced by photosynthesis. If there were no photosynthesis, we would not have an oxygen-rich atmosphere today. Therefore, when you see a planet with an atmosphere full of oxygen, you can be almost certain that there is photosynthesis on that planet. Some of my astronomer colleagues even speculate about what might happen if you find industrial pollutants in a planet ES atmosphere. For example, you might detect traces of unnatural substances like CFCs that we produce here. These kinds of unnatural elements, produced not only by plants but also by a civilization, could be detected. You can think about that. So at least for now, we have the ability to search for life by examining the atmospheres of these planets. As I said before, we are searching very seriously for life on Mars. Why? Because there is a definite possibility that life may have existed there in the past, because we know that water existed on the surface of Mars. However, we also think that there may be water in the subsurface of Mars. So perhaps microbes that existed billions of years ago may have survived deep underground. So we may find traces of life on Mars. In my view, even if this is not certain knowledge, it is potentially a major discovery. Again, this is not a scientific certainty. The reason we build giant spacecraft to go to Mars is because we want to explore it. That is, we do not have definite knowledge. If we had definite knowledge, we would not build spacecraft to go and look. Yes, but I think this is very exciting right now. In this context, there is a concept called the Fermi paradox, which may have been first articulated by the physicist Enrico Fermi in the 1930s. Let us think about the Milky Way galaxy. We know that this galaxy has about 400 billion stars. Recently, we have been discovering that the stars we can observe have planets around them. We now know that there are thousands of planets in distant star systems. This shows that planet formation is quite common. So let us say there are 400 billion solar systems. Our galaxy has existed for 11 or 12 billion years. So the question is this: if there are civilizations out there, and if they have survived, then at the very least they should have spread throughout the galaxy or left behind remnants of their activities. These civilizations would have robots capable of self-replication, mining, self-repair, and rapid multiplication to colonize the galaxy. I can say that we are quite close to doing this ourselves. By close, I mean give us about 10,000 years. But in principle, we know that we can do this. And if we still exist, we will colonize the galaxy. 10,000 years is a blink of an eye. These events have had 11 billion years to occur. So the question is, why do we not see traces of other civilizations? The answer is not known for sure. Perhaps other civilizations are rare. Perhaps civilizations go extinct before reaching that stage. Or perhaps civilizations do not explore. Nevertheless, this is difficult to understand because exploration is the essence of science and something like the driving force behind it. First and foremost, we must address the reasons behind civilization. This is truly an important question, and we do not have the answer. Enrico Fermi is one of the great Italian physicists who founded modern physics in the 20th century. Fermi's research and findings in his field are quite remarkable. When you earn a degree in physics, you will spend a lot of time studying Fermi's equations and theories. He really is a great scientist. However, the paradox is one of the things he spent the least time on. It was something he mentioned almost offhandedly. And the question is, where are the aliens? The core point of Fermi's paradox is this: we know that we live in a large universe, in a large galaxy. For the purposes of this discussion, let us limit ourselves to the Milky Way galaxy. We know that the Milky Way galaxy has roughly 400 billion suns, and we now know that most of these suns have planetary systems around them. That means there are trillions of planets. The galaxy has existed for almost as long as the universe, about 10 billion years.